Drumlins are another depositional feature. It's basically a low oval mound, and typically it's in a group, and it's consisting mainly of till that is molded by glacial action. I want you to take a look at this. For scale, this is a pretty big feature. These are trees on either side, and drumlins typically tell you the direction from which the glacier came from. This short side is called the Stas side. The glacier came from the left, went over it, and left in this way. So typically this points in a northern direction. So this is showing you the short end, the Stas End. This is where the glacier came from, and this is the direction it went in. And this is showing you a topographic map. This video kind of shows you exactly what happens. The glacier advances, it's unsorted, unlayered, and it will mold material. And as I said, they typically form in a group. We have a lot of these in upstate New York by Rochester and Syracuse. And you can see this is the short end, and this is the tapered end. These are some typical Regents questions. A piece of evidence on bedrock that shows you the direction the glacier moved. Well, striations are one, grooves are another. You can tell which direction the glacier came from. And drumlins could also be an answer. It definitely shows you the direction. And so could a terminal moraine, because terminal moraines kind of show you where it came from. The second question is the difference between an arrangement of sediment in a moraine versus an outwashed plain. Very simply, moraines are unsorted, unlayered, because they were brought by glaciers, like a conveyor belt, but outwash plains have been deposited by meltwater streams, so they're sorted and layered. The shape of a valley, it takes a river valley that was V-shaped and makes it into a U-shaped valley. Here are some other Regents questions. So let's look at the diagram. You can see this long line of X to Y. That is a moraine. They're showing you R, which is question 20, the elongated hills. The elongated hills are drumlins, and they don't tell you the age of the glacier, but they can tell you the direction the glacier has moved. The ridge of X to Y is a moraine, and moraines are always unsorted and deposited by ice. So anything behind this is formed by glaciers. Anything in front of the terminal moraine is formed by meltwater. So outwash plains, which are this area, are not formed by landslides, which is mass movement. They're not formed by ocean waves. That would be a barrier island that's formed by the longshore current. Certainly not winds from hurricanes, but definitely meltwater from glaciers. And if you see this partially buried ice block, if that becomes more buried and then melts, that could become your Kettle Lake. This is a close-up view of moraines that are on Long Island. We have the one on the south shore is the Ronkonkoma moraine, and that, when this was sea level was much lower, it extended all the way through Martha's Vineyard and Nantucket. On the north shore, we have the Harbor Hill moraine that extended out into Cape Cod. Now, there is some scientific evidence that perhaps the Ronkonkoma moraine is not from the same ice advance as the Harbor Hill moraine. Some scientists feel that it's a recessional moraine, but most people think it might have been two separate advances. So they think that this is the terminal moraine from the first advance about 21,000 years ago, and the second moraine was around 10,000 years ago on the North Shore. Either way, they both form the north. This forms the North Fork and this forms the South Fork. The top diagram is one you should be familiar with. It's in my classroom. The red showing the moraines, the two different moraines. I'd like you to watch both of these videos because it does show the moraine, the glacier advancing, forming the terminal moraine, which is the Ronkonkoma moraine, and then retreating and staying in place, which it was a stationary glacier at this point, forming the recessional moraine. So take a look at both of these videos. The glaciers brought a surprising source of income for New York State. We have plenty of sand and gravel, and we sell it all over the United States. In the beginning intro on glaciers, Mr. Organic talked about the different advances we had over the course of the last 2 million years. In between these advances, we've had these warming periods known as interglacials. So we kind of wanted to look at why some people and some theories that talk about why this happens. The most accepted theory we have for why we have interglacial periods is called the Milankovitch Cycle or Milankovitch theory. In this video, he is going to go over this 3 things that they talk about, but the first page they show you is on your ESRT, page 8. We had, in the Pleistocene epoch, we talk about when we had the last ice age. So watch this and then I will comment. This is actually just a wrap of what he just said and of the 3 different things that they talked about. But the bottom line is that it seems to be about a 100,000 year cycle. Now, has global warming changed that? We don't know. But if you think about it, the last cycle was about 125,000 years ago, so maybe we are due for this. So what they're saying is perhaps we are going to go into another ice age based on the Milankovitch cycles. All 3 of these videos summarize everything you kind of need to know about glaciers. I suggest you watch all of these so that you'll have a better understanding. Thank you.